All right, let's do this last section of 5.2. It's right triangle word problems. So we're going to get us warmed up with just some basic questions, no word problems, helping us find the missing sides given minimal information. So it says find the exact values of the indicated variables. Well, notice our angle of theta is given, 30 degrees, and then hypotenuse is 15. So we're going to have to do two different equations because we solved for two different variables. So let's find x first, right? Okay, so let's find x. Well, x is the adjacent side, and this is the hypotenuse, right? So I have to decide which trig ratio uses adjacent and hypotenuse. That would be cosine. So I would say the cosine of 30 is equal to x over my hypotenuse. So I simply would just use some algebra and multiply both sides by 15. So I have x equals 15 times the cosine of 30. This is in degree mode, so make sure you're in degree mode in your calculator. I would get 12.9904 for x, okay? And that's fine. That's what x is. Now, I need to find y. So the y side relative to our angle theta is the opposite. So I need to write the ratio that uses opposite and hypotenuse, which is my sine. So the sine of 30 is equal to y over 15. Again, using just basic algebra, multiply both sides by 15, that will give me y. So in my calculator, I'm going to get 7.5, okay? Let's try the next one. Y and R is my hypotenuse, right? They give me x, which is the adjacent side, and they give me theta. So I'm going to be finding hypotenuse and opposite sides. This time, let's start with y. So that would be opposite and adjacent that I have to use, because I only need one unknown. Opposite and adjacent would use tangent. So I would say the tangent of 30 is y over 105. So using my algebra, if I solve for y, I'm going to have 105 times the tangent of 30. Again, we're in degree mode. So if I multiply that out, I get a y value of 60.62. Let's go 622. Okay, so there's y. There's that length. Now let's find our hypotenuse. So what ratio uses adjacent and hypotenuse? That would be cosine of 30. Adjacent is 105. Hypotenuse is the unknown. So we're going to do a little more rearranging. So r cosine theta, or 30, is 105. So r would be, if I divide both sides by cosine of 30, keep this together. Keep this together. So in my calculator, I would do 105 divided by the cosine of 30. And I get a hypotenuse of 121.244. Okay. So that's just your basic solving using your trig ratios. All right, so we're going to use that function, that process, in a word problem setting. So let's look at the first one here. A surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree at 71.5. How tall is the tree? So you're going to want to start every question with a drawing, okay, with a right triangle. Now, where's my right triangle? Well, this is my tree, right? This is my tree. The surveyor is standing over here. He's standing 50 feet from the base, so that's this. He measures the angle of elevation that's looking up, 71.5 degrees. How tall is the tree? So this is the opposite side that I need to find. So I look at it. Okay, what do I have? I have adjacent, and I need to find the opposite. So which trig ratio uses those two sides? That would be the tangent. So the tangent of 71.5 is equal to opposite over adjacent. So I'm just going to use my algebra and solve for x. So 50 times the tangent of 71.5. When I do that, I would get 149.434. Make sure you put units on word problems. This is feet. The tree is 149.434 feet tall. That makes sense, right? Okay, look at the next one. You are 200 yards from a river. Okay, so here's my river. I'm 200 yards from it. rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. That means at a diagonal, right? Find the acute angle between this path and the river's edge. So the acute angle is this one right here. This path I took and the edge of the river. Remember, the river's over here. So now I'm solving for an angle. So where's my right angle? Okay, it's over here in the corner, right? So let's think about, relative to my angle, I have the opposite side and I have a hypotenuse. So I have to use the sine function to get me there. But it's theta that I need. So it's the sine of theta is equal to opposite over hypotenuse, which we can see that that's 1/2. So the sine of theta is 1/2. You can use your calculator or you can use your unit circle. What's the inverse sine of 1/2? That's what theta will give us. So if you use your unit circle, find the inverse sine of positive 1/2, you would get pi over 3. Or if you use your calculator, you would get 30 degrees. Either one works here, okay? Either one works. Let's try the next one. Find the length C of the skateboard ramp shown in the figure. Find the horizontal length A of the ramp. So length C is the hypotenuse. Okay, so let's look at what we have. This is opposite our angle. A is the adjacent, C is the hypotenuse. So we're going to have to find both. Doesn't matter really which one you start with, but I'll start with A. So to get A, I would be using adjacent and hypotenuse, which I'm going to need to use tangent of that 18.4 is the adjacent side, or no, tangent's opposite over adjacent, right? So it's 4 over A. 4 over A. Now if I solve this, just multiply both sides by A. Now keep the tangent of 18.4 together. Those are cohesive units. We don't separate those. So to find A, I have to take 4 and divide by the tangent of 18.4. When I do that, I get 12.024 feet. Okay, great. Now let's find the hypotenuse. Now you could do several things. You could do Pythagorean theorem since you know the two sides, or just use a trig ratio to find your hypotenuse. So opposite and hypotenuse would require a sine function. So sine of 18.4, the opposite is 4, the hypotenuse is the unknown. So we're going to go through the same motions we just did. So sine, or C times the sine of 18.4 is 4. So then C would be, I'm going to come over here. So if I divide, I would have C equals 4 divided by the sine of 18.4 in my calculator. When I do that, I get 12.672 feet. There you go. That's how you work it. Now let's look at our last problem. Okay, let's try this one out. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer, the angle of elevation is 9 degrees. So you have to look a little higher. Approximate the height of the mountain. Okay, so we know it has to be a right triangle because that's what we're doing, right? This is what we're trying to find is the height. So if we start, it says the initial angle of elevation right here is 3.5 degrees, right? And it says then we traveled 13 miles to this point. And now we still have a right triangle, but now the angle of elevation is 9 degrees. So what we don't know is this length right here. So we have two unknowns, don't we? Really, all they want to know is the height of the mountain. So we're going to have to do some fancy trig here. So the first thing I would do is separate out these two triangles and look at it, okay? So if I separate the big triangle out, here's my height. This distance right here is 13 plus x, right? And the angle of elevation is 3.5. The smaller triangle, still a right angle, still the height. This is x and this is, that's not 9. That's the angle of elevation, should be 9. Angle of elevation is 9. Okay, so we're going to use this to find the height. Ultimately, we need to find height. So let's set up two separate trig ratios, okay? So let's do the small triangle first, okay? If I need the height, I'm looking for height, I would notice that the x is the adjacent, height is the opposite, isn't it? So what ratio do I need opposite and adjacent with? That's tangent. So I would say the tangent of 9 degrees is the opposite over the adjacent, isn't it? Now remember, what am I looking for? I'm looking for height. So I'm going to solve for h. So if I rearrange, I'll have h equals x times the tangent of 9. All right? What about the larger triangle? Let's do the same thing. We still have opposite, we still have adjacent, right? It just looks gnarly, no big deal. So we're still going to use the tangent, but this time is 3.5 degrees equals h over 13 plus x. Keep that together. So now h is equal to, when I multiply, x plus 13 plus x times the tangent of 3.5, okay? Now, since these are both h's, can't we just set them equal to each other and go from there? Yes, we can. So let's do that. Let's say x times the tangent of 9, now keep that tangent of 9 together, equals x plus 13 times the tangent of 3.5. All right, so now, before we go too far, let's explore what we need to do. We need to distribute this tangent over here because it's a binomial, right? So what's going to happen? So I have x times the tangent of 9 equals, I'm going to zoom in so I can write it clearly, x times the tangent of 3.5 plus 3 times the tangent of 3.5, right? Or 13, that's a 13, I'm sorry. 13 times the tangent of 3.5. All right, why did we do that? We did that because we need the x terms to be together on one side, don't we? So I'm going to subtract x tangent at 3.5 from both sides. And then what do I get? I get x times the tangent of 9 minus x times the tangent of 3.5 equals 13 times the tangent of 3.5. Now, that looks really gross, right? But that's okay. We're going to get there. I can factor out an x out of both of these. So I'm going to do x times the tangent of 9 minus the tangent of 3.5 equals 13 times the tangent of 3.5. You still with me? Now to solve for x, I need to divide by this guy, the tangent of 9 plus the tangent of 3.5 on both sides. Now I can put all of this in my calculator just the way it looks because this is a value, right? Tangent of 3.5 is a number times 13. This is a number plus another number. It's going to give me an actual value. So when I do put this in my calculator, oh, these should be minus signs, my bad. So sorry, it should be a minus, and that should be a minus. That didn't change. All right, when I put that in my calculator, if you're still with me, I end up with a value of 8.17835, and I think this was miles in this question. Now, why did I do that? Not to lose you, but just to give you an idea of how we can use trig to solve these more complicated questions. Okay? I may or may not give you one of these, so hopefully it makes a little sense. If we need to go back over it in class, we can do that. Let's jump to the next section. Determine whether the statement is true or false. This is kind of like identities. So I'm going to approach them the same way. Okay, I just happen to have values instead of thetas. Okay, so let's think about this. The sine of 60, cosecant is 1 over the sine of 60, isn't it? So let's see, if I multiply these, don't these cancel out and I have 1 equals 1? So this one, in fact, is a true statement. Look at the next one, secant of 30 and cosecant of 60. Now, these are in reciprocal identities, right? So let's put them in cosines and sines. So this would be 1 over the cosine of 30, and this is 1 over the sine of 60. Okay, now how would I know if this is true? Well, you can put them in the calculator, but I also want you to think about, remember that cofunction thing I told you about? Since we know this is a right angle here, and this is 30 and this is 60. If they're cofunctions, they are equal as long as the two angles are complementary. So since these two angles are complementary, so here's my logic. Since 30 and 60 are complementary, and cosine and sine are cofunctions, this would be a true statement. Now, you can test it out with your calculator, just to show you. Okay, so we're gonna make sure when we do this that you're in degree mode. So alpha y equals, so this would be 1 over the cosine of 30. And we do the same thing, but this time with sine, 1 over sine of 60, the complementary angle. And look, we get the same number. So it is a true statement. You can use your calculator to validate that. All right, let's look at the last one. Now these are squared trig functions, so I'm more inclined to use my trig identities on this. All right, so let's just see what we can figure out. If you remember, one of our trig identities looked like this: 1 plus the cotangent squared of theta equals the cosecant squared of theta, okay? Just think of it, instead of theta, we're using 10. Those are replaceable. It's just the angle. But let's see if we can figure out this relationship to get a -1 on one side, all right? So if I want a -1, I'd move the 1 over here, wouldn't I? So then I would have cotangent squared theta equals cosecant squared theta minus 1. But I need a negative cosecant squared. So if I move this guy over, I'll then have cotangent squared theta equal, or minus cosecant squared theta equals -1. Now we're almost to the exact same thing, right? Well, theta just represents an angle, so I can write it as cotangent squared of 10 degrees minus cosecant squared of 10 degrees. That didn't change anything since the angles are the same, equals -1. And indeed, that is a true statement because of our trig identity. All right, so different ways you can do this. These all three turned out to be true. Does it always work like that? No, but you got to think it through. All right, we'll see you in class.